This is question number 4 from the SACE Stage 2 Physics Course Companion from Subtopic 2.5 Electromagnetic Induction. Here we have n circular loops with a radius of 8.5 centimeters, which are within a magnetic field of magnitude 3.2 microtesla. The area of the loops is initially perpendicular to the magnetic field, but then they are rotated 30 degrees as shown in the diagram. It takes 6.7 milliseconds for the loops to rotate 30 degrees. During this period, an EMF of 7.26 microvolts is induced in the loops of wire. What we need to do is determine the value of n. So we're using Faraday's law, or at least the mathematical version again, which is just the EMF is n change in flux over change in time, which we can rewrite as n change in the electromagnetic flux is just B A, where A is the perpendicular area over change in time. And again, just to make it a little bit easier for the rearranging and substituting, I'm going to write this as n multiplied by B change in area over change in time, because the magnetic field strength remains constant. It's the area which changes. Now we can rearrange this to get n on its own. So it'll be the EMF multiplied by the change in time divided by the magnetic field strength and the change in area of the loops. Now before we do the straight calculation, we need to work out what that change in area is. It's actually more difficult than it looks. So here, if we have our loops of wire, the area here will be pi r squared. Afterwards, it's rotated through 30 degrees, and so the area now is pi r squared multiplied by cos theta. Therefore, the magnitude of the change in area is going to be pi r squared take, so the initial area, take the final area, take pi r squared cos theta. Or if you want to simplify that a little bit, we can write that as pi r squared 1 take cos theta. That's a little bit difficult. So what we're going to do is calculate the change in area first, and then substitute the rest of our values to work out the value of n. So here the change in area is pi r squared. R is the 8.5 centimeters given in the question. Of course, we'll write that in meters, so 0.085 squared 1 take cos 30. And if we substitute that into our calculator, we should get 3.04 times 10 to the power of minus 3 meters squared. So now we can work out the value of n. So from before, with our rearrangement, we have EMF multiplied by delta T divided by the magnetic field strength multiplied by the change in area. And we can substitute the values from the question. So the EMF is 7.26 microvolts. Change in time was 6.7 milliseconds. Magnetic field strength was 3.2 microtesla. And the change in area we've just worked out to be 3.04 times 10 to the minus 3 meters squared, which, if we substitute into our calculator, gives us 5. And there we have it, the number of loops in the wire given all this information. It's actually a fairly tricky question. The rearrangement isn't very easy, since you need to separate out the two parts of the electromagnetic flux. and the change in area is more difficult than it looks as well. So if you're able to go through this question without getting tricked up on these fairly difficult parts of it, then it should be fine. It's a really good learning question. Hopefully you found it useful.